Let's consider a simple example illustrating how to find probabilities for a normal distribution. Suppose that the weekly incomes of shift foremen in the glass industry show a normal probability distribution with a mean of $1,000 and a standard deviation of $100. What's the z-value for the income of a foreman who earns $1,100 per week? So in this problem statement, the variable of interest x is 1,100, the population mean mu is 1,000, and the population standard deviation is 100. Substituting these numbers into the z-score formula, we get a z-value of plus 1.0. So what is the z-value for the income of a foreman who earns 900 per week? In this problem statement, the variable of interest x is 900, population mean mu is 1,000, and the population standard deviation is still 100. Substituting these numbers into the z-score formula, we get a z-value of -1. A negative z-value corresponding to a random number means that the random number is below the mean. A positive z-value, on the other hand, indicates that the random number is above the mean. Here's another example illustrating how to find probabilities for a normal distribution. Suppose now we randomly select one foreman. What's the likelihood of selecting a foreman whose weekly income is between $1,000 and $1,100? The figure on the slide illustrates where the two random numbers are. The area between them is shaded and represents the probability of selecting a foreman whose weekly income is between $1,000 and $1,100. To find the actual probability, we convert these two random numbers into z-scores as illustrated on the next slide. Applying the formula for converting a random variable x into a z-value, we obtain a z-score of 0 for x equals $1,000. This is because the random number is exactly the same as the mean of the distribution. The z-value for the other random number, $1,100, is a positive 1.0. After converting the x values into z values, we then refer to the normal distribution table to find the area between z-value of 0 and 1.0. To locate the probability, go down the left column to 1.0 and then move horizontally to the column headed 0. The value is 0.3413. So the area under the normal curve between $1,000 and $1,100, which correspond to z-values 0 and 1 respectively, is 0.3413. So we could also say that 34.13% of the shift foremen in the glass industry earn between $1,000 and $1,100 weekly, or the likelihood of selecting a foreman and finding his or her income is between $1,000 and $1,100 is 0.3413. Refer back to the problem introduced in the previous slide. Suppose we now want to find the probability of selecting a shift foreman in the glass industry whose income is between $790 and $1,000. Once again, we convert these values into z-scores. The z-score for 790 is negative 2.10, while the z-score for 1,000 is 0. We find the area between negative 2.1 and 0 z-scores as 0.4821. If you wanted to use Excel, you would use this Excel function here at the bottom. In the next slide, we show how to obtain this probability using the standard normal distribution table. We refer to the normal distribution table to find the area between the z-value of negative 2.1 and 0. To locate the probability, go down the left column to 2.1, then move horizontally to the column headed 0. The value is 0.4821. So the area under the normal curve between $790 and $1,000, which corresponds to z-values negative 2.1 and 0 respectively, is 0.4821. Why did we use the positive side of the distribution when the z-value is negative? Because the left side of the distribution is symmetrical to the right side of the distribution, hence the area from 0 to positive 2.1 is exactly the same as the area from 0 to negative 2.1. Suppose that we now want to find the probability of selecting a shift foreman in the glass industry whose income is less than $790. So using Excel, we can do this by using the function listed at the bottom of the slide. This yields a probability equal to 0.0179. In the next slide, we're going to show you how to obtain the probability using the normal distribution table. So here we refer to the normal distribution table to find the area between the z-value of -2.1 and 0. So to look at the probability, if you remember, we go down the left column to 2.1, move horizontally to the column headed 0, and we get the value of 0.4821. That's the area, remember, between the z-value of 0 and 2.1. But since the area we actually want is the area below -2.1, we subtract 0.4821 from 0.5 to obtain the final answer of 0.0179. So why do we use the positive side of the distribution when the z-value was negative? If you remember, it's because the left side of the distribution is symmetrical to the right side of the distribution. So the area from -2.1 and below is exactly the same as the area positive 2.1 and above. What about if we wanted to find the probability of selecting a shift foreman in the glass industry whose income is between $840 and $1,200? Once again, we convert these values into z-scores. The z-score for 840 is -1.6, while the z-score for 1200 is +2.0. So the area between -1.6 and 2.0, the z-scores can be obtained by using the Excel function listed below, and it yields an answer of 0.9224. We're going to verify this answer using the normal distribution table on the next slide. So now we're going to refer to the normal distribution table to find the area between a z-value of -1.6 and +2.0. We're going to go down the left column to 1.6, move horizontally to the column headed 0. The value is 0.4452, and this is the area between the z-value of 0 and -1.6. So next we're going to locate the probability for z of 2.0. So we're going to go down the left column to 2.0, then move horizontally to the column headed 0. And the value is 0.4772. That's the area between a z-value of 0 and +2. But since the area we actually want is the area between -1.6 and +2.0, we add the two probabilities together to arrive at the final answer of 0.9224. So we will say the probability of selecting a shift foreman in the glass industry whose income is between $840 and $1,200 is 0.9224 or 92.24%. And finally, what if we wanted to find the probability of selecting a shift foreman whose income is between $1,150 and $1,250? So note that both random numbers are above the mean of the distribution. This tells us that the eventual answer, or the probability, is a value that is less than 0.5. So converting the values into z-scores, we obtain 1.5 and 2.5 respectively. So then we find the area between 1.5 and 2.5 z-scores here using the Excel function listed at the bottom of the slide. Once again, actually we get that as 0.0606. And then we are going to verify this answer using the standard normal distribution table on the following slide. So looking at the table, we're going to find the area between a z-value of +1.5 and +2.5. So to look at the probability, we're going to go down the left column to 1.5, move horizontally to 0, and then we get 0.4332. That's the area between z-value of 0 and 1.5. Next, we're going to locate the probability for a z of 2.5. We go down the left column to 2.5, move horizontally to the column headed 0. The value is 0.4938. So this is the area between the z-values of 0 and +2.5. But since the area we actually want is the area between +1.5 and +2.5, we're going to subtract 0.4332 from 0.4938, and we're going to get our final answer of 0.0606.